Well, happy Thursday. Let's pull up our database project here. I'll keep working on that. Having a little bit of fun with this one here. Oh, I want my recent. Come on. Close the tips. There we go. Databases. All right. So we built our database using the SQLite browser because it's friendly. But if you want to run code on someone else's computer, you're probably not going to be on their computer building a database, right? You're probably not going to go through all those steps to build it out here. So having it get created in your code would be nice, right? We went through that step to kind of look at and see how these things would be set up, but we can do it through Python. If you haven't done database stuff before, it's a bit of a hassle, but it turns out we can just kind of copy paste. So if we go into our tables here, I just leave it in my SQLite browser. We can essentially copy paste. So I'm going to go open my database from my project. That was documents, GitHub. That's the wrong documents folder, right? Thanks, OneDrive. 298 negate databases. So find our database file, and I can see here's the code that creates it. Right. So if I want to take this, I can essentially copy paste this into my code to go create the table, and that's what the book goes through. But again, I think that's a little awkward the first time. But once we've built it out, we can copy paste. Right. So having the tool generate these things for you is super handy here. But you can check and say, hey, I want to, if the table exists, drop it. So drop means like delete the table. Don't recommend that most of the time, but if you want to get a very fresh start and make sure it's empty and fits whatever your format is, go for it. There's options here. But usually you can just say, I want to go create a table. Here's the details for that table. So whatever we were creating here, we can go run, right? Um, so we can go grab our tables out of the SQLite browser. And let's modify this one here. So you go to modify, you can just copy this text in. Now it's not going to fit on one row, which is a little bit unfortunate, but that's okay. You could, right? Kind of want to drop this all in one row. Or from here, you can do a triple quote. And the triple quote will take all of that and as a single string here, like a multi-line string with a triple quote, which is fun. We've already got our table, but sure, we can go ahead and so we're going to go cursor execute this guy here. We can execute this whole create table, but we've already got the table, right? So if you want to go about doing it that way, great, because this way someone else can run this code and they'll set up the database for them. And we've skipped over that step, but that's the, if you want to do that, it can work out pretty nice for you here. So create tables via code here. Now I'll just leave all that all commented, but you can go create them, right? To give you sort of that fresh start as we're going. Or even like a menu. Hey, do you want to go reset your database and then go recreate them all, or however we want to go about it here? We've got lots of options. But once we've got all those tables here, now the part is how do we work with the data inside of it? Right? And he's got his nice little pictures here. You can go through and see what's in it, right? We build it out. We looked at it in Excel first, like that kind of visualizes that table view here. But this idea of select says, okay, give me some data. That's our keyword here in SQL to go get some data out. So if I want to go get all of the customers here, I want to say, hey, select, and then you can give it the list of fields, as many of the fields as you want. Our customer table was kind of boring, right? I think we had ID and name from customer. Right, so whatever field you want, so you're going to say select and then field list from table name, right? We can run that, and then we get a result back that we can iterate over, a little for loop. So for every row in that, every result, right, in my cursor here, let's go and see what's in it. So if we run this one here, we see I've got, hey, two customers. I got Eric and Joe. And we can see that in our SQLite browser, right, if we wanted to go look at the table as well. So this was the customer table, and I want to browse the data. Hey, this is what was there, right? So I can get all that data back out here as we go. Right? I don't need the sequence one here. Right? Product, order item, order, customer. Right? So we can get that data. Now, if you're familiar with SQL, there's a lot of things you can do right in SQL to connect all of those pieces here, right? We said, hey, this field here, so when we looked at our order field or order table, it has a customer ID field. This relates to a customer. So in SQL, we can connect those two and we join those two tables together on this field. So I can get all that information back out quickly here. If you aren't familiar with SQL, you can do it in your application, but that's not the right place to do it, right? We want to let databases do the things databases are good at and not have to manage all that in code. But you can do it in code if you have to. And for small databases, it doesn't really matter. Once you start getting larger and larger and larger, you don't want to load a million rows and then just to go find three of them. Right? Hey, I want to find all the orders in Amazon's database and then find which ones are my orders. That won't go very fast, right? We can let the database do that. So if we wanted to run that one, so we'd say build a, let's do a new SQL here. I think it'll work well. So we're going to select, we wanted, so you say table dot field to specify these ones here. So table dot field to be specific about which ones it is. So I want the customer name, and then I want the order dot total. Right? So I want these two pieces of information, and I want to get them from both those tables, right? I want to connect the tables together here. I'm going to say from, this is order, and then we're going to join the customer table on customer.id is equal to the order.customer ID. Sort of this long little syntax here, but we're going to start with one table, and then we're going to connect it. We're going to join it together with this table and say, well, what do we want to connect with? What fields are we relating here? It says, okay, where these ones match. Technically, you can do this with other fields. It just gets really weird, and I don't know why you would. But so here's my primary key in the customer table. Here's the foreign key in the order table that relates to this one here. It'd be nice if it was automatic. It's not quite that magical yet. Okay, so we should be able to run this one here. Oh, no. Yeah. Goodness. Quote there. That's going to get me every time, isn't it? No? Uh, every time, really? I have to put this every time. I should just rename my table, like orders. That might make my life easier here. Thank you. Right. So we get out as a single row. I get the customer name and the order total here, because that's the piece of information I asked for here. So I can see, hey, what is the total for this customer. That's gonna be a little bit messy, but again, we can run that as a probably that one can be. I'll just triple quote it here. Why not? 3, and we'll go execute this one, and we'll go print that one out. And now we see Eric in order 2. So we don't have the headers, which is a little bit sad, but we could go and do our own printing for okay, I know its name and I know its total. I can print those first. Yeah. Uh, yeah. So so basic one is this one here, but then the join, right? So our join. I can't put that in the triple quote. Shoot. Okay, so join connects the two tables on matching. And the matching field, is that helpful? Thank you for asking. Yeah, I forget to put comments in all the time. Right, so where this one matches this one here, right? We can go connect them. Now, I could also connect to order item. That's going to get a little weird, right? Because we will see here. So you can do more than one join, right? We can keep on joining as many relations as you have. We go here. So we're going to join order item on my order item dot order ID is equal to order dot ID. Right, so this foreign key relates to this primary key. That's basically all the time when you join. It's what foreign key relates to what primary key. That's going to work for us. Now, when I run this, though, I'm going to get more than one row here because there's more than one order ID when I go browse my data for order item, right? So if I want additional information, right, I only took the name and the order total, so maybe I also want then my order item dot product ID and quantity. So you don't have to specify the table every time if it's unique. right? So I could just say name because there's only customer name. But if I also have a name in product, it's going to get a little confused here, right? So we can then join one more. So we can join product on product.id is equal to order item.product ID. So we'll join one more, right? And then I can get maybe the product. So instead of product ID, maybe I want product dot name and product dot price, whatever information I want out of this one here. Let me go run this one. And I'll say, okay, here's an order. And maybe I even want the order ID here, order.id, so I know which order this one's for. Stupid. So here's the order ID, here's the customer's name, here's the total price here, here's the name of the item, here's the price of the item, the quantity that I bought for this particular item here. It gets a little bit messy here, right? Because then my fields, they only match the names here. So I've got a name and a name. It's gonna be a little weird. So you can say, hey, I want this as order ID. And you give it a little string value. So if you wanted to show with a particular header here, you could ask for it. Now, when we get that back out in Python, we don't ever see those headers. So it's not as helpful at the moment here. But we don't have to do this one row at a time, right? We can look at each piece of data as we go as well. I think if we print can we just print the cursor? I don't think that's going to get me. No, we want for each row in the cursor. Let's print the row. So we just get the data out. So we could go and separate from here. Okay, I know the first field, I know the second field, I know the third field, right? This looks like a tuple here, or a tuple, if you prefer. So,
what's the last one like flip?
Which one?
What's the last one flip?
The last what is flipped? Sorry.
The last one, you got one or two jet cards, so it makes sense. You got a number, and then you got the name.
So I asked for name and then order total for this one here. So whatever order you ask for it in is the order you're going to get it in. Yep. Yeah. No, so this is name, and so then we could print out, right? So this will be print name, comma, order total. Right. Might make that look a little bit nicer here. Maybe print this one as customer ID and name. Or we can kind of label those ourselves, make it a little bit more sane for our own purposes here. Right, so we can kind of explore the data, right? But if I wanted to add more data, right? If I want to hey, let's go add a customer, we can ask the user, hey, enter your name here. Let's register you as a customer. Again, doing this with a console program is a little bit silly, but here's an example of how we can use it here. So we get a customer name as an input of enter a new customer name. Or imagine putting this into like a nice menu here. Hey, what you want to do? 1 for this, 2 for this, 3 for this, whatever here, right? As we go. And we'll get their name. And then here's where we need to use these substitutions. So this idea of putting values into the database here, where did it go here? Was it further down? I think it's further down with these question marks. There we go. When we go add data, we use this insert into values. So when in SQL Explorer, we did it by hand and I plugged the values in. If you're doing it in code, you want to use the substitution bit. And that's the part we left off on Tuesday, this being a big security vulnerability. You don't want to just take text and jam that text into your SQL query and hit run. Because bad stuff can happen because people know that's a common vulnerability here. So we're going to go grab a insert command. So this is our cursor. We're going to insert into customer. And the only thing we need to tell for customer is name, right? Because the ID auto-generates. I'm a big fan of auto-generating. You don't have to do it that way. You're welcome to track it yourself. But then you have to go know what the number is, which is really obnoxious. Okay? So all we're going to say is, hey, values this. And then the parameters we give it, right, are going to be the name. Here's my customer name. What this lets me do is, I guess we should put that all in the same line here then, right? It maps first field to first question mark, second field to second question mark. As many of these question marks as you have here, it's going to map for you from your variables, and it will make sure you don't get, we don't need the extra parentheses, nice, but you don't get any garbage SQL stuff put in here, which is a security risk. Because if someone enters for customer name, like, hey, drop table so-and-so, and we just run it, bad stuff happens, right? Now, it might just crash, but even crashing our program is probably a sad thing, if you're running some sort of interactive application. Um, we can go add another customer, and then let's go get all the customers back out here again. Oh, we'll add it this way here. All right, so what's the new customer's name? Who should we add to our database? Kevin. Oh, uh-oh. Incorrect number of bindings supplied. There are 5 supplied.
JEVIN maybe.
Yeah, that doesn't seem right. Maybe it needs the parentheses?
I think it kind of looks
We
like
didn't want the parentheses. Let's try it again. Nope,
I think it's
5
just be
supplied.
separate letter, and that's the problem.
Yeah.
It shouldn't be doing that. That's screwy.
Self-qualifying, probably.
Try to, maybe it'll say 3.
It probably will, yeah, because it's 5 letters. Why is it not binding here? It is a string though. It's a string value here. It takes strings. Let's see. Why? We'll get there. We'll get there. Hold on.
Maybe just
Insert into values. I feel like I've got a quote. Yeah, I got a quote in the wrong spot here. Right? Is this comma customer name? We're so close. Let's Google it here because I'm not SQLite.
How are they able to my way? I'm sorry, doing that.
Execute. Correct number of bindings. See if we get a hit here. 11 supply. Yep. Error. Execute. Use parameterized queries. Insert into values. That all looks fine. Question mark. Looks like it should go. All right, customer name is an input. We named ours cursor when we opened the connection here, right? When we got the connection cursor. I like full names. So customer name. It should already be a string, right? You shouldn't have to make it a string again. If we did Tim, he said, yeah, we get 3. So it is doing it letter by letter by letter. That's obnoxious. All right, well, that hit didn't help. Let's try the next one here. Execute. You forgot the comma to make your parameters a tuple. Huh. Or, oh, because it's ignoring the parentheses because they're redundant? That's super weird. It does, look, so as soon as I change that, it's picking it up as parameters, not. That's bizarre. Let's see if we can add Kevin. Hey, we added Kevin. Now we'll go look at our customers here. Let's browse our data. Customer, I don't have Kevin. Well, that's sad. Well, we missed a step. So there's one last safety thing with databases here is that you have to go and tell it you actually want to save your changes here. So you can do a bunch of things here, but not have it saved. So that last step to save your changes here is called commit. So once you've done your insert, right, or your updates or your deletes here, then you need to go and commit your change. When we were just reading the data, it didn't care, right? We can read the data, no problem here. But if we want to change something, we have one last chance to commit it here. And depending on your database management system, you can do fancy things here. You can roll back changes before committing them to say, oh, I made a mistake. Lots of extra safety sanity checks here. It's really nice. It's a really nice habit to get into to do these things in what's known as a transaction so that you don't blow away more things than you mean to, especially when you're doing deletes. Like if you go delete something and you forget a where clause here and you delete your entire table, You don't want to do that at a production database for your job. That's a bad day for everybody, right? So if you put it in a transaction, you could get one last chance to be like, hey, you deleted 100,000 rows. Crap, I want to roll it back, right? Before I actually commit here. Um, Now, it's a little bit silly that we're doing it programmatically. We're just going to hit commit anyway. But if an exception happens, right, we can bail out and not commit, right? We can put everything in a try block. And if a bad thing happens, right, we get some of these SQL exceptions like we were getting before. Um, we don't have to run the commit. So that might be the nice habit to put it in a try block.
Hypothetically, if that did happen, like what would be the solution?
Restore your database. Yep. Yep. One of my favorite quotes here, which we ran into because our vendor was it, or I think it was our partner was just an idiot. We call them Schrodinger's backups because until you've actually tested your backup, you may or may not have a backup just because you think you're backing things up. Turns out it's been failing for a month and they just weren't paying attention to their alerts, seeing that it failed for a month and we needed to restore the database. And they're like, oh, I've got one that's a month old, which is not good. That was a bad day. But anyway, so we'll commit here. Oh, no, I'm sorry, the connection, not the cursor. There we go, connection. So this is my top level connection here to the database. We'll commit, not the cursor. This goes and like saves the change. Right? So read as much as you want here, but if you're making a change, we got to go commit to save it. So now when I run this and add Kevin here, now when we go browse our data, we get Kevin. So we've committed our change. So same goes for updates and deletes. So when we talk about databases, there's like 4 common operations we'll do. We call them CRUD operations because we love acronyms and it's funny. You create data, that's insert. Right? You read data, that's our select. You update data, which is update, and you delete data, which is delete. So I don't know why we didn't use select and insert, but that's probably a weirder acronym here. But you create, read, update, and delete. Those are the common operations. So if you want to delete something, you use the delete keyword. If you want to update something, you use the update keyword. So it works out pretty well, and that's pretty standard in SQL. What you get to do is you can use these where clauses, and where clauses restrict what you're getting back. It says, hey, give me everything that matches where this thing is true. So for our case, not super interesting yet. We got to add some more data here. So let's go add maybe some more orders here. Let's go add more orders. Let's go. We can save that one, right? That's our big SQL here. Let's put this one and drop it in here. All right, so we need to go and add. So we're going to insert into order item, and we want the order ID, we want the product ID, and we want the quantity, right? For order item, order ID, product ID, quantity. So I need to add an order first because we got order 1. Let's add another order. So insert into order, and we want order had customer ID and it had a total. Thank you. Every time. So let's say this is for customer ID 2, and I don't know, order total 5. And that one, we'll add another order for customer ID 3. Let's add the order for 10. So we got a couple orders. I don't actually have the order item data. That's probably fine because we just want to play with order and look at totals here. So we can say, I want to select. You can use star if you want all the fields. This is generally bad practice because there's a chance the database changes. And if the database changes, then your code is going to do some really weird things with star versus specifying what fields you want. For now, it's easy. So from order, quote order, right? So here's this, just everything, right? I'm getting every value out. But I can say where, maybe I want the total greater than 4. And now I get just the orders that match this clause. So where this is true, I get that piece of information back, which is kind of fun. So we can start getting specific pieces of information out of our database. And this is where it becomes very useful here. We do sort of the basics of data analytics before we do all the really fancy stuff. Like, who's spending the most money? Who do I want to go send coupons to? right? Make them come back, make them happy, so they keep coming back here. These sorts of fun things. We can do with just some basic queries. Right? Just go look up some information. Yeah.
The whole post stuff is a big issue. Huh. For what points is it been posted? Like just the table itself, like the name of the columns are. Because
So yeah, anywhere that I've got the keyword, I'm gonna have to quote it here. So it can be like quote order dot ID. Wait, no, that's the table here. But if I want to like order dot ID, it's still gonna be upset with me. But I can quote order, and I can even quote ID if you want. Right. So you can add the quotes to columns, to table names, things like that.
keyword that referencing what for a certain column, what is it like referencing?
So you can
So yeah, order is I can say order by total descending, and then I can get all my information out in reverse order. So it lets you do fancy things in SQL. So because I named the table that, I screwed it up. Yep. That's all. So if it's the table order, I have to tell it in quotes, I want the table, not the keyword order. So it tries not to do the fancy SQL things. That's like the parser for that just pukes on it because it's like the order doesn't belong here. All right, so we've got that. So we can do insert. Should we build out a menu here? It's not too hard, right? So we'll print one, add customer, two, print customers, three, I don't know, add order. Oh, we should do products first, right? Add product, print, four, print products. Is list maybe better? List, print. We should do this in other orders here. We got customers, products, and tables. So print C for customer, operations, print P for product operations, and print O for order operations. Operations. There we go. That's a little bit nicer. And then we'll get some input here. Which thing they want to work on here. So that table is an input, and they'll enter C, P, or O, hopefully. Right? And then we can give them a 1 to create, 2 to insert or read, 3 for update, and 4 for delete, right? Because that's going to be pretty standard. 1 for, we wanted like list all, print 2 for add new, print 3 for update, print 4 for delete. Okay, so we'll know what table, we know what they want to do here. Okay. Now the menu is going to get a little bit ugly here. It's not tons of easy ways of going about doing that. We can do fancy things with dictionaries and substitute values in and do some crazy stuff if we want to. That would make our life a little bit easier. But you've got to get like the list of fields. So the star is a little bit helpful for listing all. Right? Adding new, though, we've got to be specific about what fields we want here. So our application needs to know a lot of things about the database. Right? They're very tightly coupled if you want your application to add and remove and update data. Because you need to know what you're adding, removing, and updating. Right? There's ways to do it dynamically, which get to be a lot of fun. But again, there's like a tool like SQLite. If we don't need to rebuild this tool, we want our program to do whatever we want to do with it here. We're not trying to recreate a SQL browser here. So yeah, doing the menu we could. It's just gonna be a little bit obnoxious. But if we wanted to let the user go do a bunch of stuff here, we can go do that, which is fun. I don't know. So if our table is equal to C, oh, we need another input here, right? So for operation is an input here for 1, 2, 3, or 4. They'll get our which table, they'll get which operation here. So if the table is C, or maybe we substitute it, right? Maybe we make a table name is a dictionary. Right? We can say, hey, C is for the value associated with that is customer, right? And then we have E, the value associated with that. I can't spell customer. There we go. I'm glad it spell checks for me. E is for product, and O is for two in a row. Friends, I've not had enough coffee. Now I'm going to want this in quotes here, right? So I'm going to double quote it so it can be quote in order here. Could be fun. And how about like if I just want to list is easy. So if my operation is equal to a 1, we're going to go run a select, right? So we can say I want to select, sorry. So my cursor dot execute select star from, and we can substitute in the table name because we've got the table name coming off of our whatever table we picked here, right? And then, so we're going to map that to my table name dictionary, table name key of the table that they entered, right? So whatever they gave me, we'll just pop it in here. Again, don't work too hard to be super fancy. You'll just get lots of headaches here. But here's one thing we could do, right? We can keep that list here. So we'll go and execute that, and then we'll go through and print every row out and see what we get here. Right. So really, we only have operation 1 at the moment here. So let's do how about for product here with list all. Oops, no, it didn't get us our substitution.
The parentheses around it.
I've got that one here. It's a different error. Select star from. I should have pulled it through, right? Table name table. Didn't even substitute it in. Well, this is going badly. That's fine. We'll just say order then in quotes. Right? I double quote it and forget the parameters. Right. And table name. Is it just table? Table equals O. Double equal sign. Thank you. So we wanted O for order. We wanted 1 for list all. Hey, there we go. All right, we got 1 order here. 1, 1, 1, 1, 1, 2. Should have gotten more from order though. Don't we have more orders? Didn't we add more orders? I didn't. They're here, but I never committed from SQLite. SQLite also has the commit button. It has write changes here. There we go. Now we'll get some more orders. Let me rerun that here. So for O for order, 1 for list. Hey, now we see our orders. Okay. Mystery solved. We had to commit on that side too. So we can list them out. This is going to be obnoxious. The substitute, I thought that should have worked. I don't know why it wasn't working. We can spend more time with that later.
You need the parentheses around the question mark.
Yeah, is that what I had? That's what you said, parentheses. I'm so confused. That's usually when we did values, right? Right? That's like, so the values gets the set of parentheses here. Direct bindings. Insert into, yeah, they're substituting table name that way.
Yeah, wait, why don't you do it like that instead of this?
With this sort of substitution?
Yeah.
So that one's not the binding mappings, right? So you want to use the parameter list in the SQL connection, not doing string substitution. Like this string substitution format is older Python and is not secure. I wonder if it's just not this order in quotes order, right? I don't think that would work for us here. Oh, 1. Yeah, same error with the syntax. Operation error. Uh-oh. Game substitution. I can't spell, but hopefully Oh yeah, from table here. Yeah. So can't use it for table names. Oh, that's a bummer. So we could do it in our code here, and that's probably safer, doing a string substitution there, because it's not user inputted information, right? It's only coming from ours here. So I guess we could do it that way then. From table name key of table here as a formatted string. This is string substitution for table name only, not user data or user inputted data. Substitution. Am I spelling it wrong? Substitution. There we go. Too many of those. O and 1. O and 1. Hey, all right. So now we get some orders here. Right. So if we want to loop this back, run it again here. Let's see if we can get another one listed here. Or P and 1. Do we not have any products? Do not have a table name product. Didn't run it. All right, P and 1. Hey, we list our products. All right, so we're getting closer here. This is not ideal. It can work here. It just gets to be a bit of a mess. So anytime we're doing that, it gets a little bit messy. It's okay. This is where code gets to be fun. So lots of ways to go about it here. Don't take user data, right? This is just table names and it's from my hard-coded list. This feels pretty safe, right? It's not, hey, what's the user's name and have them go enter it in here and they can do bad things. Like that. All right, so we did lists. If we wanted to do updates or add news, right, we'd have to know what fields we're going to go add. So we need a list of fields for each one of those things, right? That's a little bit obnoxious here. Same with updates, we need the list of fields. For delete, you want to be specific. So you probably want like the ID that you're going to delete off of, right? So we can add the delete. How about if operation is 4 for delete? Feeling bad, I've got these like hard-coded strings here now, but that's okay. Here we're going to delete from, so we need to get the ID to delete, right? ID is a input of, or the ID to delete. And now we want that as an integer value, right? Because we know these are going to be integers. Right? So we're deleting from a table where the ID is equal to. Now we can plug in our substitution value here because this is user inputted data. And then we know that was going to be a list of IDs here. So on this one, no. So we had parentheses when it was values. So the values list gets a set of parentheses here. This should be fine to substitute in this way. If it crashes, we'll find out. Maybe it'll crash on me here. All right, so we got the ID delete. We'll go delete that data. If we're doing something that's going to change it, right, we need to go and commit it. So this is something we have to go and commit here after we're done deleting. Right. Let's give that a shot. So we want to do, I don't know, which one should we delete? We go delete Kevin. So Kevin was a customer, ID of 3. So let's go to our customer table. We're going to delete something, and the ID was 3. It looks like it's gone. So if we go refresh customer here. Oh, it's not gone. Do we not? I'm sorry? I think I committed here. I don't know. Let's say test here. We get a new customer. We didn't delete Kevin. So close.
You're still doing so
Delete. Thank you. Bad copy paste. Delete from table where ID equals that. Yeah, we just selected poor Kevin. So customer, delete, number 3. Is Kevin gone? Kevin's gone. Get out of here. All right. We probably left him back at the house while we all went to Paris, right? Because
Since it's implemented, right? I remember last lecture the ID as implemented.
Mhm.
The user would put 5.
I'll take the 5. So it just keeps on going. So you never go backwards. So I don't know.
1100.
So we can go add Bob as a customer, and Bob is now number 5. Um, depending on your application, right? It's okay to delete things, but in general, deleting data is probably not the way to go about it. Because if that customer had any orders, right, now I'm not going to be able to track them back to that customer, right? So, like, if you've got an inactive customer, you probably want to add some sort of flag somewhere that says, hey, they're active or inactive. And then everything we key off of will be based on if they're active or not. Yeah.
When you're code, after the delete, one, two, one, 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 learn,
So we said where the ID matches. So that's
right?
the ID that we had them enter here. We asked them to enter the ID to delete, and then we mapped that one. So that one's probably safe, but again, don't get into the habit of doing string substitutions if you can help it. Yeah.
Overall, though, like when what that's all I that's true. Like you really like want to stick with like when you want to just do it, you know, like kind of.
So if it's only ever running on your computer, great. Use the browser if you want, it's fun. But if I wanted to take this code and give it to someone else, be like, oh, hey, you can go manage your own customer database now. We probably want the code to do all that creation work. Yep. So it just depends on what your use case is for it. And then even if you have the creation in the code, the next time your computer gets fried or you have to wipe your computer, it'll recreate it for you. So generally, it's nice to have it in the code, right? Like, hey, here's my way of setting it all up here as I go. But um, yeah, it's nice to have that backed up here. Um, and SQLite's a little special. It's meant to be like a tiny little portable database. It's not a big relational database here. We can connect into big the enterprise databases. It just takes a couple extra steps. Right? So it's not just the SQLite connection here. Right? So like I've done for MySQL. You get a MySQL connector here. Look at that. Licensing? What? I don't want to have to do any of that. Here's the installation. Here we go. So pip install MySQL connector. You just go get it out of the library here. We've got one for MySQL. It should work out pretty well. Not clicking too fast here. And then the examples here. Creating tables. Look at that. Here's the table I'm going to create. Right? Here's all the stuff I want to do. There's a couple extra things when you get to MySQL and all sorts of other values here, but that's okay, right? We'll get to that stuff. That's not the most interesting piece here, but go create it. You can even create databases themselves, right, which is fun. Lots of cool things here. With SQLite, each file is its own database. With an actual relational database management system, that program can host more than one database, right? So like MySQL has more than one database here. Actually, I have mine up installed from another class here. If you want to see what MySQL looks like, assuming it starts, there we go. And they've built out a nice little web application that you can go and manage, sort of like SQLite, but it's all web based, which is fun. Come on, launch. Maybe it'll launch. Come on. Shouldn't be that slow. There it goes. So you can see here's all the different databases here. So we've got one for stock, one for test, one for Twitter, one for Shifty. So this can host multiple. That's all. It's a much fancier system here. You can actually do enterprise level stuff with this one, which is cool. Yeah, but back to this one. So if you wanted to swap it out, right, works almost the exact same way. So SQL is a standard here that you can use basically anywhere. Every so often there's like very small syntactical changes here. They try and avoid those because it irritates people. But you get some other fun stuff as we go. All right. So we did deletes, but if this user had an order, that's the last thing I wanted to show. So let's go ahead and put an order in for Bob here. So we're going to go insert into order, and we want, we need the customer ID, and we need the total. Values for 5 with Bob, right? And then, I don't know, we'll just say $100 for his order. Make a big order for Bob. Now if I go try and delete Bob, I'm going to have a hard time, which is good. We want that to happen. So if I go to order and I want to delete, and we want to delete, oh no, I didn't want to delete the order. Sorry, let me cancel that. Delete Bob the customer. Go to customers, delete 5 is Bob. Uh-oh, there it goes. Database is, I never committed my change. Make my changes. Try it again. Customer, delete, Bob. Did it really delete Bob? Shouldn't have deleted Bob. I'm going to be sad now. It deleted Bob. What happened to his order? Uh-oh. We have an order for Bob. We don't have a customer. We don't have referential integrity anymore. We're in a sad shape here. Those not get set. They must not have gotten set here. No, it says matches.
You need to know those.
No. SQLite might be dumb. Other systems just puke on you and say you can't do that. You shouldn't be able to delete that. I think that's just SQLite. So be careful, right? Wow, really did that on me. It's sad. So deleting Bob means we no longer have his info as a customer. Probably don't want to let people do that, right? That's not going to go very well when you want to go send him a bill now because he's got open orders, right? Um, so be careful with your deletes. Don't delete items that are referenced in other tables. So again, that idea of setting things inactive is probably much better. It's a lot more work when you have to add in more things and you're storing more information here. But deleting data is generally frowned upon. Just depends what you're doing, right? So we did deletes. We want to do an update, right? So we did selects, we did inserts. So update, then the last one to update some data here. I don't think we have to do that one in code necessarily. We don't need to like make a menu for it here, but let's just go look at it here. So we'll go look at our order table. Right, so we go look at our orders. So maybe we'll say, oh, it's not Bob's order anymore. Let's make it for a different customer, right? Because Bob was deleted here. Let's put it on another customer. So this is order number 4, right? So we want to update order table, right? So we're updating the order table. We're going to set the customer ID equal to 4, where the customer ID is 5. Right, so anywhere you find customer ID 5, go set it to 4. So this could update lots of rows here. Could update 1 row, could update no rows. We don't, depends whatever the data is. Here, you don't have to go off that unique identifier, the primary key, just the ID. Here, we can do them for all of them here. And now if I go browse my order table, I see, hey, now it's for customer 4. We fixed that one here, right? Or we could go and change it. Hey, this is order ID 4, right? So where order ID is 4. Again, they use single equal signs. Drives me crazy as a programmer, but sure, single equal signs here. So we can set customer ID 4, and how about total equals, let's make them a really big order and move this over maybe to customer 2. So you can set more than one field. You just comma separate what you want to set here, where this clause matches. So the where clause we can use. Nope. Where did I highlight it wrong? No such column order. It's not order ID, sorry. It's just ID. It's my own fault. Here we go. So we set it. So now we go back and browse our data. And we see, hey, here's customer 2, $1,000 for that order. Right, so you can comma separate them here if you want. So I'll just throw that in as a comment here for update. Where the lift operation is, so 3 was going to be update, right? So you'd have to get, what are you updating here, right? You have to get a lot of pieces of information out and go put them back in. It can be a little bit tedious here as we're going. So gets to be a little bit awkward. Say pass, so it still runs here. All right. That been fun? Databases? They're fun. We're not going to end up using them for a particular assignment, That's a big headache, and not many of you have had database classes, but super helpful tool to have in your toolkit for anytime we want to work with data. Right? So SQLite's very small and portable, meant to be, hey, here's just a local file, not an enterprise database management system. If you want to connect to those, you can, right? Just go get their connector. Just Python's widely used everywhere, and go and grab it. And we can work with other database systems as well here. So lots of fun with that. If you haven't had a chance to yet, go reach out to a company, go find them in the DB Hoovers database. So there's going to be points for the final project that you went and asked somebody here. I didn't ask you to put your name down, who did it, what. We're just listing out all the companies because that's just more information to go find. But I'm expecting to get about 60 in there, right? Should be probably more than 60 because not everyone's going to reply here. So reach out. I'm hopeful we get some answers back. You know, depends on the person in tech, but generally people are relatively kind. That's why Stack Overflow exists. Yeah.
So what date is it up to pitch our idea?
So we're going to start those. Let me pull up our syllabus here. So we've got this last project is coming up due on the 13th. So the 13th will switch from last individual project to the final project. Yeah. So, and then you should be able to go to groups here. If you go to people and then go to groups, you can self-assign to a group. You just drag yourself into one of the groups. Ideally groups of 3. If we have a lot of groups of 2, it's going to take presentations even longer. So let's avoid pairs if possible, right? Get a third person. I think someone had emailed me and said, hey, I want to do a group of 4. And I said, well, if you want to do a group of 4, you have to do a lot more work. And I don't think I heard back yet. So that sort of idea. So you'll pitch your ideas to me, start figuring out who you want to work with now. You can self-assign, should go relatively well. The idea is we're going to look at some Python libraries and do something with it. Right? Very open-ended, right? I want you to go find something that you think is interesting and go play with it. And then for the presentation, you're going to demo it. Hey, look, I went and figured out how I could play with PyTorch. Here's a thing I did with PyTorch. Cool. Right? It's not meant to be crazy hard, but a chance for you to go explore. Now that you know a little bit about Python, go do something fun with the popular library here. And hopefully that works out well because you got people of all sorts of different concentrations and things. We don't all have to do the same project because watching 20 of the same project is terribly dull. Really, really dull to see that many presentations on the exact same thing. Okay. So we'll switch over to that as we go. Yeah, so we got a little bit of time on that, right? We got all break next week here. And then we'll finish out with data visualization. It's awesome. Midterm should be a really light week here, not a lot for the review. I'll give you a example midterm on the 12th. We'll look at the solutions on the 17th. The 19th, it will open. It won't be due until the 24th. It's untimed, open book, open notes, open internet, not open neighbor. This is your individual effort here. So just a quick check. Hey, we've done 16 chapters of Python here. Can you give me something? Right. That's the only exam that we have here. And then we'll switch gears. So I'll demo a bunch of different libraries here, just some basics. We're not going to get super deep. So the idea with whatever specific library you want, your team of 3 people will spend a good chunk of time doing something cool, right? More than the getting started demo that's out on the web, right? Like that's not very interesting. But go and do something with it beyond that. Should be a lot more fun. And there's tons of cool libraries out there. There's ones you can run web servers with Python. There's stuff you can do really cool data analysis things. You can do image processing stuff. Lots of different ones out here. You can do IoT things if you like that sort of stuff. It might be a little bit harder because you need hardware, but kind of whatever you're interested in, I'm probably open to it. Right? It's probably going to be rare I say no to a pitch. If your pitch is just lame, you're like, I want to get Hello World working. No, right? Give me something here, right? It's a 3-person project. We've got a month to work on it. Ideally, that's what does that work out to be, right? For 4 weeks times 3 people, it's 12 people weeks at like 6 hours ish. It's about 100 hours project, right? Should be able to do something cool in 100 hours, 100 man hours, right? Okay. Questions, thoughts, concerns? Make sense? We got the plan for March and April. Have a good end of February. And I will see you folks Tuesday. No, not Tuesday. Don't come. We're on break. 2 weeks.
Next Tuesday.